All right, today we're going to talk about the particle theory of matter. So we'll start with that title at the top. Particle. We're going to try to break this into 5 spaces. So what we're going to do is we're going to sort of create a rectangle space eventually in the middle, but we want to leave it open-ended. So in this one, we're going to talk about the idea that we basically added some salt to water. And when we did that, it disappeared. However, if we take one little drop of it, we notice that that little drop tastes like salt. Drawing the word, we'll draw a little particle here to represent salt. And then we're going to add it to a little cup of water. And what we're going to end up with is salt water. Now the question is, how are we going to model that? Well, what we're going to do is we're just going to imagine that that little crystal of salt breaks into individual particles of salt that become invisible in the water because they're so very small. And those tiny particles of salt go everywhere. And so this is number 1. And basically the idea is that the particles, this is giving us some evidence that particles are very small. In this next part, we'll draw a line down here, and we'll start with number 2. And so what I want us to imagine here is that we have, in this container, we have some beans, and it's basically goes up to about 7, okay? And the idea is if I added something like salt to this, instead of the level going up, right, those crystals of salt, in this case, they go in between the beans because the particles are fitting in between the spaces of the larger particles. There is space between the particles. We're gonna model that by drawing our little 2 milliliters of salt. We had 10 milliliters of water. Didn't really have a perfect addition here, right? This was something less than 12, which is what we would have expected. I'm just going to say it was 10.5. We want to try to model on here what's happening. And so what we're going to do is we're going to draw some particles here, sort of like my beans. Doesn't really matter. This would represent the water by itself. And then we have the little bits of salt over here in this one. And then the idea is that when we mix these together, these tiny little particles can fit in between the big bean-like particles. There is space between the water particles for the smaller salt particles to fit in between. All right, the second to last one is one of my favorites. It's where we take a little food coloring, or in your case, some of you had the soy sauce, and we put a drop in water. And without touching the food dye, without doing anything to this container, we see, first of all, the thing drops, oops, but it also then starts to spread around. And so we'll watch and we'll notice that by the end of this little note section, this container, without really us shaking or stirring, it's automatically stirring itself. And so we're going to model this way. We're going to draw 3 containers like this. And we're going to put a little drop of whether soy, you could say soy or food dye. One of those. And that's going in this one. And then we can imagine that this is made of little tiny particles, right? That little drop is in fact made of little particles. So in this one, when it first lands, this little drop of particles sort of stays together and sinks to the bottom. They sort of stream down like this. But if we wait, as you can see, if we wait any time at all, this container of water is going to fill up completely, just like the salt water did, with these little particles of food dye or soy sauce. And so by the end, this is completely filled with little particles of food dye, and they are taking up, they're spread around in the water column like so. So we can say here, what we're showing here is the particles are spreading out. And if you guys remember this, if you want to put in there, this is a very important process in all of science called diffusion. It's this random motion of all the particles. So this is being number 4, we'll put here. And it's this idea that no matter what, the particles are always moving. And one of the strangest things we'll find is that even in a solid, right, the particles are still moving a little bit. And that's a very unusual thing about this theory of matter. And last but not least, number 5, this goes back to our story of the egg. And the idea is we have an egg and it's got holes in the membrane. You'll remember we talked about this a little last year when we did this. So we have this egg and we have water particles in this egg spread all around inside of it. It's got a lot of water in it. And the water particles are smaller than the holes in the membrane of the egg, so the water particles can escape. Okay? But there's other particles in there that are bigger, like protein and things like that. And those are too big, so they can't get out, right? So we see this weird thing happening when we put this in some other solution, which is that the egg can shrink as the water particles escape it, leaving it still full of stuff, but the stuff that it's full of can't escape out of those little tiny holes in the side because they're too big. And this is evidence that particles have different shapes and sizes. So we have water particles. They basically are able to pass in and out of this membrane that surrounds the egg, whereas the oil or protein particles are too large. And they're basically in or out. So you'll know that they put other objects, if you remember from that video, they put this in other solutions, and those other solutions again had these large particles, and they couldn't go in. So it was only water that could go in and out. And so again, what's this showing us? It's showing us the different substances have different different sizes and shapes of the particles that make them up. Different sizes and shapes. So here's our 5 pieces, right? Space, there's always space between the particles. Particles are attracted to each other, which is why the water drops fit together and hold together. They're very, very small because we can taste them regardless of how small they are. We can't even see them, but we can still taste them. We can see that they spread around, which means that they're always moving. And this egg experiment showed us that these things have different sizes and shapes.